Okay, geometry, let's get rolling into section 8.3, trigonometry now. This is kind of the big idea here in the middle of chapter 8. So that word trigonometry, the tri obviously implies we're dealing with 3. The metry involves that we're measuring. So what we're really doing in this chapter here in this section is measuring parts of triangles. And to help us find some missing parts within triangles when we know certain pieces of information, we have what are called 3 trigonometric ratios. And these are going to be useful, everybody, when we're looking at a triangle that is going to be a right triangle. So we know we're going to have one right angle. And unlike our Pythagorean theorem problems, when usually we knew 2 sides and we were trying to find a third, now they might just be telling you the length of one side. Let's just say one of them was 8, and the measures of one of the acute angles in the figure, like maybe this right here is a 23-degree angle, something like that. So this would be a setting where the Pythagorean theorem isn't going to help us, let's say if we wanted to find the length of our hypotenuse here, but these trigonometric ratios will. So there are 3 basic trigonometric ratios here: sine, cosine, and tangent. Now what I have written out here is the actual full names of each of those ratios. They're more often known by their abbreviations. With the sine, we just leave off the E and write SIN. Cosine is just going to be COS, and then tangent is just going to be TAN. So if you have a scientific calculator in front of you right now, there's a very good chance that you've got buttons on that calculator that look like these. Now, we don't want to sound foolish here by calling them sin, cos, and tan. We go ahead and we say the whole words of sine, cosine, and tangent. So the first thing we have to do before we can understand how to use these ratios is to understand their very definitions. So the sine ratio, everybody, in a triangle is the ratio of its opposite leg divided by the length of the hypotenuse. Okay, so sine is a fraction, everybody. Opposite leg over hypotenuse, or better yet, it's a ratio. Cosine is very similar, but that one is going to be the ratio of the length of the adjacent leg in a triangle compared to its hypotenuse. Okay, so sine is opposite over hypotenuse, cosine is adjacent leg over hypotenuse, and in a tangent now, we're going to take the opposite leg and divide that one by the adjacent leg. And those are the definitions, everybody, of the 3 trigonometric ratios. So sine is opposite leg over hypotenuse, cosine is adjacent leg over hypotenuse, tangent is opposite leg over adjacent leg. Now, as you've probably heard before, there's a silly mnemonic device for helping us remember what these things are. And that mnemonic device, I'll spare you the whole story here, which is all, of course, made up, is SOHCAHTOA. And SOHCAHTOA, if you can remember how to say it, and more importantly how to spell it, helps you remember what all of these things mean. If you take a look at the first letter of each word, S, C, and T, that's what you have for sine and cosine and tangent. And what the SOH of SO means is that the sine ratio is opposite leg over hypotenuse. SOH. Cosine is adjacent over hypotenuse, CAH, and there we go. And in the TOA, we have a TOA. That means that tangent is equal to opposite leg over adjacent leg. So this is the silly little thing that you guys should try to help make yourselves remember here and memorize so that we can remember what the 3 trigonometric ratios each means. Okay. So we're going to do a couple of different things with this. We're still not really using this stuff to solve problems just yet, but for now, let's look at our directions. All we're being asked to do here is to write the 3 trigonometric ratios for each acute angle. So we've got a right triangle here, ABC, with the right angle at C. That means that angle B is an acute angle and angle A is an acute angle. So we're going to try to write out the 3 trigonometric ratios for each of those. We're going to start with the sine of angle A. And one habit you guys want to get into, every single time that you write a sine or a cosine or a tangent, it always needs to be followed by an angle. Sometimes that's going to be a number. They might say the sine of 38 degrees equals blah, blah, blah. But when we don't know the measure of the angle, we like to use the name of it, which was angle A here. So we're going to try to come up with the sine of angle A as a ratio or a fraction. So going back to SOHCAHTOA, the sine ratio means opposite leg over hypotenuse. So what I have here is a little stick figure. We're gonna say that's us. And since we are trying to find the sine of angle A, we are gonna stand right here at angle A and kind of look out at the world around us. The definition of sine is opposite leg over hypotenuse. So for opposite leg, let's take a look at where you're standing. We can tell right away, regardless of where we're standing, that since C is the right angle, 61 is the hypotenuse. That means that 11 is a leg and 60 is a leg. One of those is opposite, or across the figure from where you're standing. One of them is adjacent, which means right next to where you're standing. Well, from your perspective, standing at angle A, the opposite leg is the one that's across from you over here, and that's going to be 60 for the opposite leg. And the hypotenuse, regardless of where you're standing, is going to be 61. Everybody, that's the answer to the first question right here. When they say to write it as a ratio here, they're just looking for a fraction. And the sine of angle A is 60 over 61. That actually means that the length of your opposite leg and the length of your hypotenuse are very, very close to one another. All right, let's keep going now. The cosine of angle A. The definition of cosine, think about SOHCAHTOA, is adjacent leg over hypotenuse. So from where you're standing here at angle A, the adjacent leg, the one that's right next to you, the one that you're touching, is the 11. So that goes in the numerator. The hypotenuse hasn't changed. That's still 61. And the last one here for angle A, the tangent of A. All right, SOHCAHTOA reminds me that tangent, T-O-A, tangent means opposite leg over adjacent leg. So again, you're still this blue stick figure standing here at A. The length of your opposite leg across the figure from you is 60, and the length of your adjacent leg is 11. Now that's an improper fraction, but with trigonometry, we never bother taking the time to rewrite that, say, as a mixed number. Writing tangent of A as what, 5 and 5/11ths doesn't do us any good at all, so we're perfectly fine leaving that as an improper fraction. So those are the three trigonometric ratios for angle A, but the directions did say to do it for each acute angle, and the other acute angle is angle B. So I'm going to switch colors on you guys here. Let's go green for this one, and we are now going to take the time, shouldn't be quite as long, to find the sine of angle B, the cosine of angle B, and finally the tangent of angle B. All right, and here we go. Again, these are all fractions now, and what you probably want to do is move your stick figure. You are no longer standing at angle A, but you've now moved and you're standing over here at angle B. So let's think about it now from that perspective. Sine still means opposite leg over hypotenuse, but from where you're standing at angle B, the opposite leg across the figure from you is over here. 11 is the opposite leg. The hypotenuse, though, hasn't changed. Regardless of where you're standing, the hypotenuse in this triangle is always going to have a length of 61. So the sine of angle B is 11 over 61. Cosine of B. Cosine means adjacent leg over hypotenuse. So from where you're standing here at angle B, the adjacent leg, the one that's next to you, the one that you're touching, is 60. So 60 is your adjacent leg, and the hypotenuse hasn't changed. That's still 61. And the last one now, the tangent of angle B. Tangent is opposite leg over adjacent leg, so from your perspective here at B, the opposite leg is 11, and the adjacent leg right here is 60. So, a couple things to talk about before we wrap all this up. First of all, there were 6 questions really here that they were asking, and we gave them 6 answers. So all of this is the answer to this question. We've now come up with the 3 trigonometric ratios for each acute angle. The other thing to notice, though, it would be silly if we didn't point this out right here, there are some connections between these 2 sets of answers right here, and maybe you were clear on them already. The sine of angle A, which was 60 over 61, is exactly the same as the cosine of angle B. And maybe not surprising then, the cosine of angle A, the 11 over 61, is exactly the same as the sine of angle B. And the other thing to notice then is that your 2 tangent answers, 60 over 11 was the tangent of A, 11 over 60 was the tangent of B, these are reciprocals of one another. So not the same thing, but we took the fractions and just flipped them upside down. So something worth noting maybe for the future. And we're going to do the same thing with this problem here. We're going to do sine and cosine and tangent of each of the two acute angles. But this problem's a little bit tougher, guys, because you were only given two of the three sides. So there's a way, I'm going to go ahead and put an X right here. There's a way that we've learned earlier in this chapter to find a missing side when you know two of the sides in a right triangle. And that, we shouldn't forget, is the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So one of our legs is x, we'll square that. Plus the other leg, which is 4, we'll square that, equals the hypotenuse, which is 10, and square that also. So x squared plus 16 is going to equal 100. We'll subtract the 16 from both sides and get x squared is equal to 84. And boy, not a whole lot happens here, I don't think. We go to take the square root of both the left and the right, and I am pretty sure, you guys, that the only perfect square we're going to find that goes evenly into 84 is 4. So if I've got this right, this becomes the square root of 4 times 21, and that square root of 4 simplifies here. X is 2, and the square root of 21 just tags along. One way I can double check that is to think, does 21 have any perfect square factors? Well, the only factors of 21, other than 1 in itself, are 3 and 7, neither of which is a perfect square, so I feel pretty confident in saying that that is as good as we can get x to be. So I am going to erase this x over here and write in this value now of 2 times the square root of 21. And with that in mind, I think we can now go ahead and start answering the question. Let's take a look here. We're going to begin with the sine of angle L. All right, sine means opposite leg over hypotenuse. So here's angle L, which means that you are standing right over here, looking across the triangle here. Opposite leg on the other end of the figure from where you're standing at L is the piece we just found, 2 root 21, and the length of your hypotenuse is 10. Now, the one thing you need to remember to look for if you want to get full credit on a problem like this is, can we simplify this ratio? And we've got a 2 and a 10 out there that can both be divided by 2. So we need to do that. The 2 divides out completely, just leaving you with a 1. So that's the square root of 21. And then the 10 divides by 2 to make 5. Not going to get any better than that, guys. So the sine of angle L is the square root of 21 over 5. Cosine of L, I think, is going to be easier than that. Cosine is adjacent leg over hypotenuse. So again, 10 is the hypotenuse. That makes 4 and 2 root 21 the legs. The one of those two legs that's adjacent to you, your stick figure standing at L, is 4. So 4 is your adjacent leg, 10 is your hypotenuse. No radicals here at all. And then we're going to divide out the 2 yet again and get a 2 over 5 for the cosine of L. And the last one we've got right here is the tangent of angle L. And the definition of tangent is opposite leg over adjacent leg. So from L, the opposite leg is the 2 root 21, and the adjacent leg is the 4 that we had here. Once again, you're looking for a common factor that you can divide out, and that's once more going to be a 2, leaving you with just the square root of 21 on top and a 2 on the bottom. Okay, halfway home on this one. I'm going to switch to red now to do the second part of this. And I don't have a ton of room, so let's see if we can't cheat just a little bit. Okay, the sine, now not of angle L, but angle N. That is the other acute angle. So let's move your stick figure from L and let's bring it down here to N. Okay, so the definition of sine is opposite leg over hypotenuse. So from where you're standing now at N, your opposite leg is now 4 and your hypotenuse is now 10. So the sine of N is going to be a 4 over 10, which simplifies to a 2/5. But you might have noticed that's the same value we got here for the cosine of angle L. Okay, now the cosine of angle N Well, let's see if we can use that trick here. The sine of L is going to be the same as the cosine of n. So that's going to end up being the square root of 21 over 5, because these two things are going to end up being the same. The last one here is a little bit tricky. The tangent of angle n. It is going to be the reciprocal of this number right over here. So that's going to be a 2 over the square root of 21. But we're not allowed to leave that radical in the denominator. So we've got to multiply both the top and the bottom by the square root of 21. Oh boy. So the the tangent of n ends up being 2 times the square root of 21, and down on the bottom, root 21 times root 21 is 21. So boy, that's a mess, guys. Nothing else simplifies. So the tangent of n is 2 root 21 over 21. Okay, so those were two problems where we were just being asked to come up with the ratios themselves. Okay, and we got that. Now we're going to start to be a little bit more specific here, and actually I think these problems are maybe going to be a little bit easier than what we were just dealing with. So let's start solving for x and y in triangles here where we're given one side length and one acute measure. Okay, so this is what we have here. The Pythagorean theorem would not help us because we only know one side length. You need two in order to use the Pythagorean theorem, so this becomes a trigonometry problem. And one thing you guys might want to do, as you're just getting started here, is to write out SOHCAHTOA at the top of every page or every problem that you're looking at, because the first decision we need to make here is whether this is a sine or cosine or tangent problem. So let's talk about that. You always want to picture yourself standing at the measure of the angle that we know. So you, my friend, are located right over here. Looks like your head's falling off sideways. You might want to see a chiropractor. Anyway, let's take a look at what's going on. We want to find x first. So you want to ask yourself, relative to my position right here, which side is x? The opposite leg, the adjacent leg, or the hypotenuse? Well, 16 is clearly the hypotenuse, and if you want to label that, go right ahead. From where you're standing, x is the leg that's next to you, so that is the adjacent leg. Y is all the way across the triangle from you, so that is your opposite leg. Okay, so if we want to find x, from your perspective right here, x is the adjacent leg. We can't use y because we don't know that either. 16 is the hypotenuse. We need to use adjacent and hypotenuse. So we go up to SOHCAHTOA, and the only one of the three ratios that uses adjacent and hypotenuse is the cosine ratio. So this is a cosine problem. So we start by writing cosine, and remember what I said a moment ago. Every single time you write sine or cosine or tangent, you always follow that up with an angle. Well, we know the measure of this angle here. It's 33 degrees. Okay, so we'll go ahead and put cosine of 33 degrees equals, and now we're going to put a fraction. Cosine is adjacent leg over hypotenuse. So from your perspective, the adjacent leg is x, and the length of the hypotenuse is 16. So that is an absolutely essential an absolutely essential first step here, guys. We've got to get this equation set up correctly. But from here, we got to remember what it is we're trying to accomplish. We are attempting to solve this equation for x. So ask yourself the same questions you always do. What is being done to my variable, and how do I undo that? Well, here's your x. It's being divided by 16, and we undo division by 16 by multiplying both sides by 16. I do it once on the right, and everybody, this is important. You do not want to put the times 16 here on the left, because then what's going to happen is you're going to put those numbers together first, and that's going to be problematic. You always want to multiply the 16 out in front of the trigonometric ratio. You'll see why in a second. So on the right side, this is x divided by 16 times 16. Those 16s cancel each other out, and we're just left with an x over there on the right side, which I'm now going to move to the left. And for the left side, which I'm now going to move to the right, we can simply put all of this into our calculator in one step. So, not doing anything funny, guys. I'm going to go ahead and type in 16. You can hit times right now, but you don't have to, times the cosine of 33. And I'm going to close my parenthesis and hit enter, and I ended up with x equals 13 point, I'm going to go with a 40 2. We're going to round to the nearest hundredth. And I'm going to box that up. One thing I should have asked first here, make sure that your answer makes sense. The only thing we knew about this triangle was that the hypotenuse was 16. That had to be the longest side, so as long as x is slightly smaller than 16, I'm happy with that answer. Okay, so that's x. Now we're going to try to find y. And unfortunately, this is a whole new problem, but it's not that bad of a whole new problem. So let's go blue here. And let's work on this. Okay, you are still standing at the 33-degree angle, but now you're interested in y, which is the opposite leg. You still want to use the piece we were given, which is hypotenuse. So which of the 3 trig ratios uses opposite and hypotenuse? Check SOHCAHTOA, that's sine, opposite over hypotenuse. So we are going to write now sine, the same angle, 33 degrees, is equal to, and this ratio is opposite over hypotenuse. So from your perspective, the opposite leg has a length of y, and the hypotenuse is still 16. Now, just like last time, ask yourself what's being done to my variable and how do I undo it? Well, just like before, y is being divided by 16, so we are going to multiply both sides by 16, again remembering to put the 16 out in front of the trig ratio. These 16s cancel each other out. And here we go. We now get y equals, and I'm going to type in 16 times sine of 33. And that's going to get me an answer of 8.71. And again, that seems realistic. Y looks like the shortest side in this triangle, and the 8.71 is the shortest piece that we came up with there. Okay, so that's our first trigonometric problem, guys. We found the 2 unknowns within this problem using one cosine ratio and one sine ratio. So that's an example of what to do when you were given the hypotenuse. Let's take a look at example B. Now in this one here, you've got your right angle up on top, but now the hypotenuse, again, I always think it's a good idea, is across from the right angle. So I always like to put a box around that. You might even want to label that is your hypotenuse. Now, no reason to change this. That's the angle you were given, 68, so that's where you should think about yourself standing. That means that the 13 is the adjacent leg. It's a leg because it touches the right angle. It's adjacent because it's right next to you. So 13 is the adjacent leg, and x is the leg that's all the way across the figure from you, so that's the opposite leg. So probably a good idea to think about those things right at the beginning. Okay. So let's go ahead with this one, guys. We're going to go ahead and we're going to try to find x first. No reason. You really can do either one in either order, but I like to go alphabetical. So if we're going to find x, you are standing here at the 68. The x is your opposite leg. And we have to use the 13, the piece that we were given, which is the adjacent leg. So if you think about SOHCAHTOA, which one uses opposite leg and adjacent leg? This is going to be tangent now for the first time. So we're going to write tangent. The angle that we were given, the angle we're standing at, is 68 degrees. And that equals the ratio of tangent is opposite leg over adjacent leg. So from the 68 degree angle right here, your opposite leg is x and your adjacent leg is 13. Okay, once again, our variable is x. What's being done to it? It's being divided by 13. We're going to multiply by 13 on both sides. Once here and once way out in front of the tangent. Okay, these 13s cancel, and we are going to get x equals, excuse me, and now we're just going to type in 13 tangent of 68. You don't even need to hit times there. Now, as I look at the diagram, 13, the adjacent leg, looks like the shorter leg here, so I'm expecting an x value bigger than 13. And my calculator tells me that the answer is 32.18 if I were to round that to the nearest hundredth. So that seems realistic to me. Okay, let's shift gears now and let's try to find y. Again, no need for you to move. You're still standing here at 68, but the y is your hypotenuse, and we still want to use the 13 here, which is still the adjacent leg. So which trig ratio uses hypotenuse and adjacent? That would be cosine. So cosine of a 68-degree angle is equal to, and this ratio now is interesting. Cosine is adjacent leg over hypotenuse. So from the 68, your adjacent leg has a length of 13, and your hypotenuse has a length of y. Now this might not look different, but it really is compared to the last three that we've done. For the first time, we've set up a trigonometric ratio, and the variable is located on the bottom of that fraction. That hasn't happened yet. So what a lot of people want to do here, and it's wrong, so don't write it, is they see division and they say, okay, I've got to multiply both sides to get rid of that division, and they put a 13 here and here. The problem, guys, is that these 13s are both numerators. They don't cancel each other out. Here, this 13 was a numerator, but this 13 was a denominator, so those two did cancel. That does not happen here. So, I'm going to show you a quick trick for what to do here every single time your variable ends up on the bottom of a fraction. What you're allowed to do is flip-flop the top left and the bottom right in any expression that looks like this. The y now moves to the left side. Y equals. The 13 stays where it was on the top right, and the cosine 68 now moves into the place on the bottom right. Cosine of 68 degrees. Okay, so that's an expression now we can put into our calculators. I'm going to type in 13 divided by the cosine of 68. Now before I hit enter, let's think about y. We know that y is the hypotenuse of our right triangle, so it has to be the longest side. That means that this y has to be longer than 13, but it also has to be longer than this x value of 32.18 that we came up with before. So I'm expecting something bigger than 32.18. My calculator gave me 34.7 and a 0. You should include that at the end if the directions say to round to the nearest hundredth. All right, so it wasn't a whole lot longer than x, but that's what we came up with for the values of x and y. So this little trick right here, guys, is one that is going to come up a lot, maybe as much as 50% of the time when you do this. If your variable's on the bottom, you do this little flip-flop trick, and you switch the left side with the bottom of the right. All right, and one last example that we're going to do here together, and this one is significantly different from the last two. In the last two problems, you were given the measure of one side of a triangle and the measure of one acute angle, and you were asked to come up with the remaining sides. Now, you've been given the measures of two sides. The two legs of this triangle are 22 and 23, and you're being asked to come up with the measures of the angles. So let's talk about how this is different. You can find either of these two angles you want first, but most people like to go alphabetical, so we're going to find x first. There's you, standing at x. Now, here's your right angle, which means the hypotenuse is over here. That's unknown. The two legs were given to us, and the 23 is across the figure from you, so the 23 is the opposite leg. The 22 is the leg that you're touching. That's the adjacent leg. So we need to think about SOHCAHTOA, and we need to decide which of the three trigonometric ratios will help us here if we're using the opposite leg and the adjacent leg. Well, opposite and adjacent, that's going to be tangent. Now leave yourself some room here, guys. It's important, and you'll see why in a second. So we write tangent, and what I've said 2 or 3 times already, this is important that this idea sticks. Every single time you write a sine or a cosine or a tangent, it always gets followed by an angle. Now sometimes that's numerical, like in the last problem we wrote the tangent of 68. But sometimes, like in a case like this, we don't know the value of this angle right here, so we go ahead and just put tangent of x equals. Leave yourself some room, and now here comes the fraction. Tangent is opposite leg over adjacent. Opposite leg is 23, and your adjacent leg right here is 22. So for the first time, we've set up a trigonometric ratio where the variable is the angle itself, and then over there on the right side, we don't have any variables at all in the fraction. We know both of those numbers. So ask yourselves the same questions. Where is my variable? What's being done to it? And how do I undo that? Well, This takes some new vocabulary here, guys. Here's your variable. What's being done to it? They are taking the tangent of it. Tangent is its own operation, so this is not multiplication. This is not addition. It's not a square. Tangent is its own operation. So when you ask yourself, what's being done to my variable? The answer is they're taking the tangent of it. And then the question becomes, how do we undo a tangent? Well, there's a way to do it. They were not very creative in what to name it. The operation that will undo a tangent, that is the inverse operation of tangent, is simply called, you ready for it? Inverse tangent. And it looks like this. We write tangent and we put a little -1 as a superscript, which really looks like an exponent, but it's not. That's the symbol here, everybody, for inverse tangent. So we're going to take the inverse tangent of x. But I bet you know what's coming now. You can take the inverse tangent of the left side as long as you remember to take the inverse tangent of the right side as well. Now, here's the really good news. Inverse tangent and tangent are inverse operations. So when you go to take inverse tangent of x, the inverse tangent and tangent simply cancel each other out, and your left side is just plain old x, which is exactly what we wanted. Now on the right side, we're going to go ahead and evaluate this. Now the question we are asking now, the inverse tangent of 23/22, really means what angle out there has a tangent ratio of 23/22. So the way you're going to get to inverse tangent, on almost every calculator out there, you're going to hit the second button and then the tangent button. So I've got inverse tangent now, and I type in now in the parentheses 23 divided by 22. And when I hit enter, my calculator gave me an answer of 46.27. Let's think about what we just found, and let's think if it's realistic or not. X is the measure of an acute angle within this right triangle. It's acute. I knew it had to be less than 90, and it is. Furthermore, this 23 is a little bit bigger than this 22 right here. That means that X, being across from the longer leg, has to be the larger acute angle. The Y is across from the smaller leg, Y's got to be the smaller acute angle. Well, since X is a little bit bigger than 45, which would be the cutoff point between the two acute angles, I feel really good about that answer here. And now, what I think you guys are going to feel really good about, I'm not going to make you do the trig again to solve for Y. We know that because this is a right angle here, we know that X and Y have to add up to 90 degrees. So if we want to find Y, and we already know the value of X, all we need to do is take 90 minus the 46.27 that we came up with just a moment ago. So in my calculator, I'm going to hit 90 minus 46.27, and that got me 43.73 for the value of Y. All right, so that method there of using inverse trig is something you guys are going to need to practice a little bit, because that can be a little bit weird, but we'll get the hang of it. Okay, guys, that's a wrap on our 8-3 notes. I will post a video with some worked out solutions to the homework, so let's practice that and see how we do.